Okay, another really helpful calculator stroke to finding the derivative of the point is this function dy dx. And this is it's a little bit quicker, I think, sometimes than n deriv. So one way that we looked at before is n deriv, go y1, comma x, comma number. And now we're looking at this function dy dx. So I think dy dx sometimes will be quicker, sometimes won't be. You'll want to become fluent with both of them, but I just want to show you both so you can start practicing them both. So again, let's just use the same function just so that you see how they're used the exact same way. Again, we're looking at f of x equals x squared, and we want to find the derivative at x equals 3. And we know what it should be. We know that it should be 6 because we found that before. But to use this function dy dx, there's just some very easy steps. So step 1, into y1, put your function. And then graph the function. And then you go to one of the most helpful keys on your 83 or 84 calculator. You're going to press second calc. And you're going to go down to dy dx. And just press enter there. And once you press enter, you're going to tell the function you're going to put in the number 3 because we're trying to find the derivative when x equals 3. So put in the number. Really simple 4 steps. Let's look at that and how it works. So we get out our calculator. We put in our function. In this case, it's x squared. Let's get the steps so we can read them. So I just put in my function, x squared, and now I'm going to graph it. And I get the parabola that I would expect. So now I'm going to press second calc. So second calc, the yellow button, and I'm going to go down to dy dx, press enter. And now I'm going to put in the number. So I'm going to put x equals 3. So I just press the number 3, press enter, and it tells me here dy dx equals 6. So that's a nice graphical way, I think, of getting the derivative using the calculator. We get a nice picture of my function here, and it tells me down here that my derivative with respect to x equals 6 at x equals 3. So once again, getting the same numbers as I would expect for the derivative of x squared when x equals 3. 4 easy steps. Very handy calculator function. After watching this video, you should practice this a couple times and make sure that you know that you can do these steps and commit these to memory so that when we come into class the next time, we can get right to work and I don't have to re-explain it to you. They're right here. Rewind it, rewatch it, learn it, commit it to memory. Okay, so the last thing that we're going to be talking about today, or the last big idea, new idea that we're going to be talking about today, is using that function n deriv to get a graph of a function, not just a function, but of the derivative function. So working with the function we've been talking about today, f of x equals x squared, got something that looks like this. Here's f of x. And in a previous class, we, in a number of different ways, showed that the derivative function equals 2x. So here would be my derivative function of 2x. What we're going to do today is, let's say that we don't know the derivative function, and we're given some random function. We want to be able to graph that derivative, because being able to see a graph of the derivative as we continue on is hugely helpful. So right now we're just building a tool set, and the tool that we're going to be building today is how do we get a picture, a graph of a derivative function. So steps, really simple. First step is put f of x into y1. And then the second step, well, we want to graph the derivative function. So in y2, what we're going to put is n deriv, and we know how to do that. y1, taking the derivative of x. But instead of putting a specific point here, which we did before, like before we put 3, now we want to find the derivative for every single value of x. So for any value of x, we're going to find the derivative. So y1, comma x, comma x. And that's it. That's all we do. And this finds derivative for any value of x. And then plots the value so that we get a complete picture of the derivative function. So let's see it. Let's just work with y equals x squared again. So the first step, put the function into y1, we did it, and then into y2. We're going to put n deriv. So just as a reminder, we press math. We go down to n deriv. Press enter. Now we need to press y1, so we go vars, y vars, function, y1, comma x, comma x. And now what we're going to do is we're going to graph the function and its derivative together. Sometimes this takes a little bit of time just for the calculator to think, but there it is. That's what we would expect. We have the parabola y equals x squared right here, and then this line y equals 2x there, the derivative of that function. So in the next section, what we're going to be looking at is using this n deriv to graph a derivative function for us to start making some real strong connections between the derivative and a function. But for now, the skill that you need to be able to do is just the following. Put the function into y1 and in y2, make the derivative function and then graph it. So the last thing that we're going to do today is just look at a synthesis. We've talked about finding equations for tangent lines before, but now we're going to use the calculator to do that. And we're going to use either one, it doesn't really matter, either n deriv or dy dx, for us to find the derivative of a function. Remember that the derivative is the slope of the tangent line. So we're going to use n deriv or dy dx to find an equation of the tangent, just write tangent line to this following function when x equals 1. So if we want to get an equation for a tangent line, basically you just need to do two things. One, get the slope, and the slope is the derivative of the function. And two, get a point. But to get a slope, again, let's use our calculator, and I'll just use n deriv for now. We take our calculator, and we need to put the function in. So our function is x squared times cosine x, and make sure that the mode that you're in is radians. So we're in radians, and once we have that in, we can quit out, and now we're going to do n deriv. So since I already have n deriv there, I could just press second enter, and it shows up again. You know, if I press second enter, it shows up again. Nice skill to have, but since we are new with n deriv, let's just go through the whole thing. So math, go down to n deriv, and now we need to put y1, so vars, y vars, function y1, comma x, comma 1, because we're finding it when x equals 1. And this is going to tell us the derivative of the function at x equals 1, which is the slope of the tangent line at x equals 1. And we get that it's 0.239. So let's take a quick picture of that. Now that we have the derivative, now we need to find the second thing we need to get a point. So we know that we're looking at the derivative of the function when x equals 1. So let's go back to a graph of my function. It's this cool looking cosine function that's been affected by x squared. And I want to find what is the value of that function when x equals 1. So I can use second calc, find the value when x equals 1, and it gives me the point, y equals 0.54. So let's take a picture of that. Now that we have the slope, and the slope is given right here, and a point right there, we can find the tangent line. The tangent line, as a reminder, tangent line is y equals m x minus x1 plus y1 using the point slope form. So our tangent line would be y equals 0.239, rounding to 3 decimal places, x minus 1 plus 0.540. Just to illustrate where these points, this here, this there, this from there. And what I can do now is graph the tangent line on top of my function. So just to illustrate how well the tangent line's working. So if I go into my calculator and into y2, I'm going to graph the tangent line, which is 0.239, comma, x minus 1 plus 0.540. And I'm going to zoom in just a little bit, so zoom 4. And what we're looking at is this right here. This is when x equals 1 and y equals 0.54. And we notice that the tangent line does a very good job of approximating that curve in that small little area. I could zoom in just a little bit more. Zoom in at x equals 1. Oops. Zoom in. So here's my tangent line, just touching, just kissing the curve at that point. So that's this last question is a synthesis question, because we were already finding equations for tangent lines. So now we're just using the calculator to A, get us the point, and B, get us the derivative or the slope of the tangent line. So it's using the calculator to make things a lot easier for us.